In this video, I introduce a DiscoGAN. Discover cross-domain relation with a generative adversarial network uses GAN to discover relations between different domains and transfers the style from one domain to another, while preserving the key attributes of input. A generator GAB maps input XA to XAB. A discriminator D uses a sigmoid function to determine probability of his input sampled from the real data. Loss functions LGB and LDB are defined as here. We use this type of loss function to train the generator to avoid gradient vanishing. DiscoGAN is a style transformation framework. The generator of DiscoGAN uses a RGB image as the input instead of a noise vector. The goal is to generate an image with the attributes of the input image and the style of the reference image. An additional decoder is added to generator for reconstruction to ensure that XAB in the domain B contains the key attributes of image XA. A distance function, for example, mean square error D is defined as a reconstruction loss here. The loss error GAB of the generator consists of two parts, namely reconstruction loss and generation loss. So discriminator has a loss error dB, which includes two parts. One is for the real data, one for the generated data. This additional decoder GBA keeps the attributes of the input XA in XAB during training through reconstruction. DiscoGAN coupling model learns a bijective mapping between the domain A and the domain B, namely manifolds of coupled images is overlapped. GAB and GBA share the same model parameters. The total loss LG of two generators is defined as a sum of four terms, which constrains attributes in the generated image during training. The total loss LD of two discriminators is include LDA and LDB, forces the style transformation. Therefore, a bijective mapping is achieved, and a one-to-one correspondence can be discovered, which is defined as a cross-domain relation. For more details, please check with these references. Thank you. Bye.